Morning, people. Morning. Oh my God. Alright, today, if I remember correctly, today is coordinate geometry. If I know how to know. Kelsey, is that what we're doing? You can't ask Kelsey. Book where you read. Book where you read is sweet here. I know it's coordinate geometry. Oh, look, sir. Ali, take it. Use Chinese. They're my students, one of them. Ready? Oi. Alright, good. Do we have our own graphs or do we have to get selling graphs again? So we get, tell us you need to get your own copy. Rule up my graph here. And then we're going to do a quick recap of what we've done last week. Every Wednesday will be a graph class. You can get your own pack. Makes it easier for you to get the job done. Then you have to purchase it with graph card, or you have your own graph? Graph card, or you have your own graph? Okay, 10. Finish. Okay. Using a 1-to-1 scale. Nothing's not going to change. I'll let you know if anything changes. Remember that when you're putting the points on the axis, they should be small enough for you to see. They should not be big enough for me to see. They should be small enough for you to see and not big enough for me to, not even the persons who are watching this can see my numbers. Try to keep it nice and tidy. Come again? You have to check your graph from last class. But yes, that's it. What did we say we're going to do? We're going to use the graph that we did from last week to continue this lesson. That's what we said. Is that what we said, Shanice? Did we say that we're going to use the graph from last week to continue this lesson? Do you have the one from last week? You worked? So you missed the first graph class? You missed a class? Oh, do you have it? You sure? You've never missed a class. Oh, I'm psycho. Late as in don't come any at all? Or late as in late to come into class? Oh man, never seen this class yet. Alright. So can somebody confirm if that's what we said? Anybody in here actually did in the class last week? Is that what we said? So we said we're going to use this graph. to finish this lesson. Alright, so Shanice, you need the points. You know how to plot points? So can someone provide her with the points, please? Well, you have to leave. Let me just write down the points. Shanice, the points are A is, based on this graph, is 2, 5. A is 2, 5. And B is 6, 1. That's what I'm seeing here. R is X. X is minus 3, 4. Minus 3, 4. And Y, or is this T? I think it's T. Minus 8, minus 3. Minus 8, minus 3. And then I think this is R and Q. No, P and Q. P is minus 2, minus 3. Minus 2, minus 3. And Q is 5, negative 7. 5, negative 7. Those are the points that we had from last class. So for those who forgot their graph, which I told you not to, but you forget it anyways, you're going to have to plot it over again. Like me, I have to do it over. So 2, 5, that's 2 across and 5 up. So I'm about there. It's almost right. And then 6, 1, that is 6, 1. That's about here for me. It's about right. This is my A, so that is my B. Now we draw a line. I'm a little short. I'm kind of lean still, to get the idea. I'm kind of lean. Minus 3, 4. So all of these over here are minuses. Minus 3 and up 4. That's about there for me. And minus 8, 3, minus 8, minus 3, all the way out here, minus 8, minus 3. So that's about here. It's not accurate, guys, because I'm on a blank canvas, but you're on a graph, so you should be more accurate than I am. Only about here, maybe, about here, somewhere, maybe here. And then my next points are, okay, so this is going to be X and Y. That's my line. And the minus 2, minus 3, minus 2, minus 3. And then, of course, 5 minus 7. 5 minus 7. Down here, somewhere. So that's this line here. Everybody should have a graph looking something like this. There's 3 different lines. Where's your graph from last class? I have it? Yes, you don't need to plot it. Just take it out. You don't need to replot it again. You have it. That's the graph that looks like this. Yeah, that's it. No. Oh, this is from the previous class. It's from the other math class. So, plot it, you plot it in. Did you just use one of the small lines? I told you to use the bright ones and the medium bright ones. You just use one of the middle ones. So you have to draw those. Remember we said, guys, use the bright ones and the medium bright ones. Don't use the little tiny ones that go between to draw it. Alright, so everybody has a graph that replicates the one that is on the board. Kelsey, where's the graph from last class? Totally not believe it. Alright, so let's do a quick recap. So we learned last week the purpose of, well, we learned what coordinate geometry entails. And in that lesson, we discussed that coordinate geometry basically is a discussion as it regards to plotting points and drawing lines. And we stated that a point is a precise location on the Cartesian coordinate system or the Cartesian plane. We learned last week that this line here, this horizontal line, is known as your x-axis or your domain axis, and this one here is known as your y-axis, your co-domain axis, or your range axis. Okay? Going up, positive integers; going down, negative integers; going to the left, negative integers; going to the right, positive integers. We learned that the center is known as the origin, and the coordinate of the origin is 0, 0. Okay? The coordinate of the origin is 0, 0. We learned that when we are plotting a point, we plot the x-ordinate value first, followed by the y-ordinate value next. Always x, then y. In other words, we always travel eastern or western, followed by northern or southern. So it's always either this direction or that direction first, followed by going up or down. Okay? And then you put your position here. We then extended the concept of plotting a point to drawing a line, where we said that a line is a continuous series of points in a straight line. Okay? You can have a collection of points, but they're not in a straight line. We call them scatter plot. But when the points are in a straight line, then technically that's what we call a straight line. Yeah? So basically, to draw a line, we only need two distinct points. It can either be at the beginning and at the end, or it could be any 2 points in the middle of the line. So we can extend it. You can do one at the beginning, one in the middle, or one in the middle and one at the end. But as long as you have two distinct points that you can connect, then that's how you draw a line. I'm not sure, did we go as far as talking about the different types of gradients? So we stopped at plotting points. That's where we stop? Right, perfect. So today now we're going to be, Shanika. Okay. Alright, so today now we're going to go into gradient. So hit up that for me. Gradient. Slope. So the topic is gradient / slope of a line. Gradient / slope of a line. So gradient and slope are the same words. I never stay with it. So here. Gradient / slope of a line. Gradient / slope of a line. S-L-O-P-E. So by definition then, let's go. A gradient is the measure of steepness. A gradient is the measure of steepness. A gradient is the measure of steepness of a line. Of a line. Of a line. Full stop. The gradient is indicated by the symbol. The gradient is indicated. I should have said denoted. Denoted is the correct word. The gradient is denoted not indicated, denoted. The gradient is denoted by the symbol M, that is lowercase m. So put that in open and close quotation. M, open and close quotation. That is the letter that we use to represent gradient. Not G, not S, M, lowercase m. Has to be lowercase, because there's another M in math. It's capital M. Pardon me? After? Denoted by the symbol M. Remember, it has to be lowercase m, which means that going forward, anywhere you see that little m here, it will represent the gradient of that particular line. Now, let's look at the different categories of slopes that we have. Okay? Now, but before we actually look at the categories of slopes, let us understand that the slope is not something that you can locate on the graph. It's not on the graph. It's a value that represents the steepness of the line. So it's not on the graph. So when you get a gradient like minus 3 over 4, it doesn't mean that it is minus 3 and up 4. That's not what it means. Okay? It's not located anywhere on the graph. It's just a number. It's like saying I am 30 years old. Okay? You don't see 30 on me anywhere. Well, I mean in my hair and my face. But yeah, but it's like giving something a value, but you can't locate it anywhere specific. Okay? So the gradient is just a value that tells me how steep a line is. Okay? So, when we look at the categories of slope, we're going to have what is called neutral slope, infinite slope, positive and negative slope. Okay? We're going to have a look at what they look like, first of all. Let me just clear this. I'm going to have to replot the point. So categories, C-A-T-E-G-O-R-Y, categories, R-I-E-S, of slopes. So first one that we're going to have is, start off with this one. If you end up with a line on your graph that looks parallel to the y-axis, or it's vertical, then this basically has no slope. Well, it has a slope, but the slope is extremely large. So we cannot assign a value to it. So we say that the slope is infinite. So this is called an infinite slope. Or you might find textbooks saying that it has an undefined slope. Okay? It has an undefined slope. So an infinite slope, or sometimes referred to as a undefined slope. The value of this is an extremely large number. So we use the symbol sleeping 8. A sleeping 8. The number 8 lying down, sleeping. That's a symbol for infinity or infinite. So it's a straight line coming down like that. Okay? So that means the y-axis. If I were to ask you as a fill in the blank question, which of the axes below has an infinite slope? X-axis or y-axis? The answer would be y-axis, because y-axis is a vertical line that has no slope. And just to put it in more perspective, an infinite slope is like the wall, which is why we cannot climb the wall. Okay? Well, at least for Spider-Man he can. But for a normal human being who doesn't have any superpower, then you can't climb a wall because the steepness of the line, steepness of the wall. Okay? The next slope that we have is in fact this one. And that is what we call a neutral slope, or it's a slope that is equal to 0. So we say this is a neutral slope, or we say that slope equals 0. And an example, a typical example of a neutral slope would be the actual ground that we're standing on. Which is why when you stand on the ground like I'm standing now, okay, I'm not sliding down, okay? I'm not sliding. I can stand here for 100 years and don't move. Or, just to make that better example, if I take the bottle of Pepsi here and I were to put it on the table is actually a horizontal surface. So let's say that there's no force acting on the building. Let's say that the building is going to be here for 100 years. And I put this Pepsi right here and come back the next 100 years. It's going to be here. As long as no breeze don't blow, or nobody will bounce it, or there's no shift in the building, no earthquake, or nothing like that, okay? It will stay there because the slope is 0. There's nothing, there's no force acting on it, so it now will move, okay? So that's a neutral slope, 0 slope. Again, if I ask you the multiple choice question, okay, or fill in the blank, might drop in some of those on the quiz just to give some persons extra marks. Well, give some persons chance to get marks. Which of the axes below has a neutral slope? It would in fact be the x-axis. Okay? Now, I'm almost sure, okay? I'm almost sure you might have watched movies, you might have heard somebody talking, and them say, oh, the mountain is steep, man. You ever heard that before? The mountain is steep. Okay, what they're trying to say is that the mountain has a slope. So when a mountain has a slope, or when something has a slope, or when a hill has a slope, it can either be positive or it can either be negative. So when it's a positive slope, it looks like that. It slants this way. That's a positive slope. Okay? So we don't have a value for it yet until it's on the graph. So this is a positive slope. Okay? And one way that I used to use to remember this, right, because sometimes it gets a little confusing, like I don't remember which one is positive or negative. I put up my left hand and I get a positive slope. So if you turn towards the board or you look on your book or you put up your left hand like so, it gives you the impression of a negative slope. Sorry, of a positive slope. And of course the opposite is the right hand. It's a negative slope. So here we have a negative slope. N-E-G-A-T-I-V-E, negative slope. So that means the steepness will be a negative value. And for this here, the steepness will be a positive value. We don't know, 1.5, 2/3, 3/5, we don't know. Okay, we're going to find out in a moment. So a neutral slope, infinite slope. So I may ask you on the quiz, not this one, in the term, look out for that one. It's going to come in a variety of different types of questions. Okay? Infinite slope, neutral slope, negative slope, positive slope. I will ask you to list the different types of slopes that exist. Easy 4 marks, I think. Those two there. Okay. So those are the categories of slope. Now to test, look at the graph that you now have on your paper. What category does this fall in? This particular one. This is the positive slope. So when you finally learn how to calculate the value of this slope, you're expecting that the result is supposed to be a positive value. For this one, what category of slope does this fall in? Negative slope. Because this one looks like this one. So it's a negative slope. So you're expecting that the value is going to be a negative answer. Negative 1.5, negative 2.5, negative 3, we don't know. Okay? And then of course this one that I had here looks a lot like this one again here. So that's also a negative slope. Okay? Alright, good. So we've looked at the fundamentals, you know, the basic understanding, the intuitive understanding of the slope. Now it's time to calculate. How do we calculate the value of a slope? There's actually 2 ways to do it. And when I tell you that there are two ways, it doesn't mean that you have it don't mean that you have you have an option, right? But there's going to be some questions that you're given where it kind of makes sense to use the graphical method, and may have some questions where using the graphical method can be quite strenuous in terms of, because the question is worded for you to take up a graph, draw x and y axis, plot the points, do the graphical method because that's the one you prefer. Kind of a bit too much, especially when you only work 2 months. And then for you to actually have the graph in front of you, and because you don't really like the graphical method, because you don't really get it, then you want to use the formula, which forces you now to have to read off the points, write them down, plug them into the formula and work it out. So yes, you have an option in terms of preference, but based on the question, right? Sometimes it makes more sense to use the graphical method, and then sometimes it makes more sense to use the formula method. So we're going to be looking at both. Alright, so write this down for me. You can write at the back of the graph or in your book, it's up to you. There are 2 calculative methods. There are 2 calculative methods. There are 2 calculative methods for the gradient. There are 2 calculative methods for the gradient. The first one, the graphical method. The first one is the graphical method. 2, the gradient formula. 2, the gradient formula. So, head up for me, subheading, graphical method. Let me explain the graphical method. May I erase here? Right here? So for the graphical method now, this is how we do it. A gradient is defined as the change in y. A gradient is defined as the change in y with respect to x. With respect to x. A gradient is defined as the change in y with respect to x. Therefore, m, that's the symbol for gradient, m is equal to rise divided by run. M equals rise divided by run. This is the graphical formula. M equals rise divided by run. So rise in itself is kind of self-explanatory in terms of when something rises, it kind of gives out the idea that the thing is going. But in math, there is also the negative rise. Okay? So when we say rise, it's not limited to just something going up. Okay? It means that it's a vertical shift. So the rise means a vertical shift. And a vertical shift can mean that it's going down or it's going up. Once it's going up, it is positive, and if it's going down, it is negative. The run, again, that is kind of self-explanatory as well, because if you're running, you cannot run straight up or run straight down. You have to run on a surface, a horizontal surface, okay, where there's no steepness. So the run is what we call a horizontal shift. So your gradient is going to be the amount of shift made up or down compared to the amount of shift made to the left or right. Now, how do we actually construct this on paper? How do we construct this rise or run business on paper? Now, the first thing you do, all right, and listen good, if you get a question, okay, if you get a question that is graphically constructed already, or even if it's a case where you're required to construct the graph, draw up your Cartesian plane, got your points, draw your line. The first thing you do is, after plotting the point and drawing the line, can I erase this? After plotting your point and drawing the line, which you have already done from last week's class, we're going to start off with this one. You're going to use your ruler and with broken lines, draw a vertical line coming down like this. Draw the line as far until you're in line with the next point. So draw a vertical line, broken lines that is. It would be nice if you could use your pen, although you're not really allowed to use pen on a graph. But just for the purpose of, keeping the thing color-coded, draw a straight line, whether a blue or a red ink pen or something. Okay? Or if you want to use your pencil, that's also fine. Broken lines. From A, you already have your graph from last class. You should draw the line coming straight down until you're in line with the next point. What is the graph from last week? Oh, okay. So that means you have to plot those points over. So you have to go ahead and plot this. So 0 is here, 1, 2. So we discuss this after. 1, 2, 3, 4, 5. So go ahead and plot your points. Those are the points over here. So have you done that? Okay, so it has come down all the way here. Then you're going to use the line again and draw a horizontal line here towards B. So your line should be bold. Your line should be bold. And these constructed lines should be broken. Okay? Don't make them bright enough, make them light. Very light, almost like you can't see them. Okay? So make sure that the actual line is bright, but these constructed lines are broken and very light, because it's not really a part of your diagram. You're just there as constructions. So what you've just done, by coming down, going across, you've just constructed your rise distance and your run distance. Now your task now is to count the amount of large squares coming down. Not the tiny ones now, the large ones. So from A, count with me. 1, 2, 3, 4. Can you confirm if you have 4? Do you have 4 bright lines coming down? 4 bright and medium lines. Do you have those? Janelle? Okay, 4. Now, because you are coming down, direction is important. Because remember that we have positive slope and negative slope. So if you're coming down, it's not just 4, it is negative 4. So put that right here, negative 4. Now you're at this position here. Yes. Chelsea. Alright guys, just a correction in my English language. You're counting the lines, okay? Because I have some students saying that it's half a square. You're actually counting the lines coming down, alright? Not the actual square. Okay? So you're counting the lines coming down. So 1, 2, 3, 4 lines coming down. Okay? So it's 4 lines coming down. Remember that when you're counting, you cannot count where you're starting from. When you're walking, nobody walks and I say, walk 10 steps ahead. There you go. 1, 2, 3. Nobody does that. If you're going to start walking, you step 1 step ahead. So when you're counting on the graph, it's the same thing. You're here. 1, 2, 3, 4. NJ? Problem?
No, sir.
Okay. Going across in this direction then. Help me out. From my graph, which is very inaccurate, I'm getting 1, 2, 3, 4 as well. Are you getting 4? But in which direction am I going? I'm going to the right, which is? So that's positive here. 4. So now I've basically calculated my rise shift and my run shift, or you want to say my vertical shift and horizontal shift. I can safely say that M is equal to my rise is -4 and my run is 4, so my slope is -1, and that's it. So my slope is -1. This is A, as A here. A is actually in the it is 2, 5. Alright, we get that? Next bit? 4 divided by 4 is how much?
7.
4 divided by 4 and 1? It's good? It's 4 divided by 4, 1. So that's it? 4 divided by 4 is 1. Yes, Kelsey. Here? I'm running in this direction. I'm running in the positive direction of the x-axis. Remember, that's how we already said that going this way is always positive. So if I'm running positively in that direction. Catch up? Any questions from anybody? So? Good? Smart person? Feel good? Nick? Good? Alright, let's go on the one. Let's do this one. So I showed you an example where the rise can be negative. This example I'm going to do it the opposite way then. I'm going to show you that the rise can be positive. So in this way here, even though the line is xy, remember that the start and the end, we said this last week, that the start and the end is relative to the person looking at the graph. So even though the line is xy, it's safe to say that the starting point is x and ends at y. But what if I wanted to start at y and end at x? Isn't it the same line? xy is the same thing as yx. So even though the line is xy, it is safe to say that I should go down, then go across. But who say I cannot go? Who say I cannot go up and go across? I'm still ending at the edge here. Okay? So for this one, just to show you, I'm going to go up. So with your ruler, again, with a different color ink preferably. Come up like this with broken lines until you're in line with X, and then run across and hit the Y. Run across until you hit the X. So come up from Y and go across the X. Yes, Jada. Why is the line not touching the point, Jada? I lose what I want. It's missing the point. It's supposed to hit the point like that. So you're going off. Alright, so count with me. My only is, as I said, my own is a little bit off in terms of appearance. Right, so you have to work with, you have a graph more accurate than mine. From the looks of this, it looks like I'm counting 1, 2, I don't know, 1, 2, 3, 4, 5, 6, 7. I got 7. You got 7? In which direction am I going? So it is positive 7. Touch it? What happened? Lost? Okay. Going up, positive 7. And going this way, looks like I'm going 1, 2, 3, 4. I got 5. Did you get 5? Touch it, what happened? You're looking at the points.
Yes, sir.
You didn't have your graph on last? Okay. So 5, I got 5. So is it positive or negative? Which direction am I going? Tell me, right or? Which direction am I going? Which direction am I going? When I'm going this way, I'm going right. So it is positive, no? Positive. So for this particular then, I can say that M is equal to rise over run. So my rise is positive 7 and my run is 5. We can leave it as 7/5. We don't need to convert it to a decimal. We don't need to convert it to a mixed fraction. All of those are not necessary. We work with improper fractions and proper fractions. Yes, Nesbeth?
Sir, why are negative 5 or negative 8?
Why is it what?
Is it negative 5 or 8?
Here?
Yeah.
Negative 8. Yes, Kelsey? Alright, so we're good? Alright, so do this one by yourself. This one. It's up to you, it's your choice. You can choose one, but this one that we had here, the one that you had, there were supposed to be 3 lines that you had from last week. I had erased mine. This is the last one here. Minus 2, 3. What's up? Minus 2 and down 3. That's right here. And 5 minus 7. That's 5 minus 7. I see 5 minus 7. So this line now, here's where you have a choice. Your choice. Your choice. Now here where you're going to get the same answer. So if you have a student here that decides that they want to go down and across, or another student decides they want to go up and across, you're both going to get the same answer. Remember, direction is important for your numbers. If you're going down, it's negative. If you're going to the right, it's positive. If you're going up, it's positive. If you're going to the left, negative. You're supposed to stick, well, you're all supposed to get the same answer. So your choice. I did one for you, where we're going down and across. I did another one for you, we're going up and across. Your choice, decide. Decide what you do, yeah.
Sir, we got it.
Pardon me?
Done.
You got it?
Yeah.
Good. So, we went down and across. Minus 5. We get minus 5 over 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Now come good. Very good. Minus 4 over 7.
7 over 4.
Did you go across? Did you go up?
Sir, I went
You can't go across and out. It's rise over run. Rise over run. Is it negative 4 over 7 or what? Negative 4 over 7. Negative 4 over 7. Where else? Negative 4 over 7. Negative 4. No, but then it's supposed to get positive 7 over 4. Sorry, it's supposed to get 7 over negative 4. Alright, buddy, can you confirm that the answer is minus 4 over 7? Some of you guys might get 4 over minus 7, same thing. 4 over minus 7 is the same thing as minus 4 over 7. It is not the individual numbers that are negative, it's the whole entire fraction that's negative. Yes. So, negative 4 over 7. That's what everybody's saying. So, negative 4 over 7. So, you can see that you have a choice. So, when you get this on the quiz on Monday, because it's there, this is there. You get it on the quiz on Monday, you have a choice as to what you decide to do. There's going to be one question there that requires you to do it graphically, and there's going to be one question there that requires you to do it this way that I'm going to show you now. So head up for me. Eh? Well, yeah, lose 2 marks. Yes, 2. 4 marks. 2 for the graphical and 2 for the formula. You want the marks? Yes. Yeah, man, you can buy them on there. Oh, no, my bad, no. Let me give you a better one. Alright, good. Jada, good. Alright, so that's the graphical method. Instructions will be given to you as to which method you should use. If there's no instruction given, then you can choose whichever method you prefer. Okay? So what? Good. Alright. Moving on next then. Today, gradient formula. So the gradient formula is the next one. The gradient formula is the next one. Touch it, what happens? What happened? Alright, let's go. The gradient can be determined by the formula. The gradient can be determined by the formula. You just said the gradient formula. You need to stop reading that book.
Determined by the what?
The gradient can be determined by the formula. M equals y subscript 2 minus y subscript 1 divided by x subscript 2 take away x subscript 1. In a moment I'll explain to you what that means. It looks a little weird at first when you see it and be like, oh, let me get it. Let me first clear up something that I've seen over the years, where once I explained it, okay, students tend to always do them one. This does not mean y squared. That's why I said y subscript 2. So don't square the value and say that's what I said. I didn't say that. Y subscript 2. These subscripts are basically points location. Okay, are your ordinate locations. Now let me show you how you can determine the x1, the y1, the x2, and the y2. Let's say I give you a point, say A. Pay attention. Anyways, A, let's say I gave you a point A, say 4, 7. And I gave you another point, say B, 3, 4. Because we know the gradient has to do with a line. And a line has to do with 2 points. So once it's gradient, there has to be 2 points involved. So for the starting point, I give you x1, y1 subscripts. So the 1 subscript means that it's the starting point of the line. And the ending point of the line has the x2 and y2 subscripts. So the subscripts are basically Nesbeth and Jaden. The subscripts are starting and ending. Did you hear that? Good. So the starting point is x1, y1, and the ending point is x2, y2. That is how you label your points. Now if you want to experiment, and I wouldn't call it an experiment, I choose to say that my line starts at A and ends at B. But what if you decide that you want the line to start at B and end at A? Pardon me? Yes, the 7 represents Y1. So X1, Y1, what if you decide that you want to start the point at B and end at A? Then you make your B be the 1 subscript and let the A be the 2 subscripts. Got it? So subscripts 1 are starting, here, ending. What time is that the person's coming? 9?
12 o'clock.
Let's go. So do we get it then? I don't want to know. You don't get it. If you get a point, Tajin, A and B, as you've always been getting since last class. The first point is X and Y. 1, 1. The ending point is 2, 2. Once you get a point, X1, Y1, ending point, X2, Y2. Ending 2's starting 1.
So we have 3 minus 4, and we have 3 minus 4, and 4 minus 7.
Precisely. So here's the formula. And we've been doing formulas from, I don't know when, we've been doing formulas. What's the fundamental rule in my class? Always write down your formula. Do not follow NJ and do it in your head. You're going to make mistakes. So if I go ahead then and I try to calculate the gradient of this particular line, okay, I would write down my formula and I would say M equals Y2 minus Y1 over X2 minus X1. Now, once you have labeled your points correctly, you label and put them in your respective position. On this, what did we label as Y2? What did we label as Y2? So that goes here. What did we label as Y1? 7. What did we label as X2? What did we label as X1? Now it goes back to basic math. 4 take away 7. Very good. 3 take away 4. Negative divides into negative. What is a negative into a negative? Very good. 3 divided by 1 is? So my slope is 3. Ali? So my slope is 3. Let's do one more before they start coming in. But we're going to do one more from the graph that we just did. Okay, we're going to do one more from the graph that we just did. We're going to use the formula to confirm that the graphical method is correct. Okay, so give me one of the points that we had on the graph earlier. Give me one of the points that we had on the graph earlier. Did you take this off? Can I erase or no? No? Give me one of the points that we had earlier. It doesn't matter which one. A, B, X, Y, or P, Q. Which one do you want? PQ, I heard it before you added. I heard PQ first. So I'm going to work with PQ. Can I raise? Alright, so go ahead, start moving on here. Run the points and PQ. You have them? Roll them down, run the points and you're not going to work on them. So the first thing you do, Touch, when you see this, first thing you do, write down your points. What is P, Touch? You need to write it down? You're lag behind. Somebody give me the points of P. Negative 2. Negative 3, correct. What is Q? What is Q? 5, negative 7. 5, negative 7. What's the next thing we do? Write down your, I don't know how many times I'm going to reiterate that. I'm going to not stop until it stick. Until you don't have a choice. Everything you do, if it's formula related, do not follow MJ and do it in your head. Write it down. You're not going to eventually catch it now. Until every time you mark your question wrong, because you do it, not eventually start writing from. Watch. Alright. Alright, so M equals y2 minus y1 over x2 minus x1. We need to label our points. Jay, do you want to label them for me? Here is what? x1, y1. Over here is x2 and y2. Have that? Jordan? You good? Okay. Plug it in. What did we label as y2? That's what we labeled it as, y2? Negative 7. Careful with the signs now, you know. So y2 is negative 7. What is y1? So this minus right here, so is independent from the minus that is here. So y2 is minus 7. Minus comes down, and y1 is a negative number. So it causes a sign clash. And so this sign clash here can cause problems. If you don't write down the correct sign clash, you'll cause problems. Divided by, what did we label as x2? Talk to me now, guys. 5. What did we label as what x1? So notice that this minus sign here is independent from this negative here. So just that one little mistake with the sign here can cost you 2 marks. Because if you make a mistake here, I can't go any further. I can't give you a half mark for just writing on the formula. And I can't give you a half mark for just putting in the number. You put in the wrong sign. So that's where I have to stop. Okay? A negative means a negative gives you a. So what is negative 7 plus 3? Or better, negative 4. Negative times negative is? What is 5 plus 2? 7. So my slope is minus 4 by 7. Was that what we got when we actually did the graphical method? So it's confirmed that the formula is the same thing as the graphical method. Finish up the other two. Well, not finish up. Confirm the grading that we got for the other two using the graphical method. Use the formula to confirm that they are in fact right. Okay? And that is it for this session. Alright, so next week, Wednesday, again, we'll pick up on this class, right? We'll see this class posted tomorrow evening. So if you need a review, if you need to rewatch the class, you can actually watch it back on the channel. If you need to get talk to you. Alright, that is it, guys. Peace. Oh, the quiz is Monday. Remember, Monday morning. Oh, the topics, my bad, the topics. Alright, so it's fractions. You know the traditional one, fractions, decimals, and approximation. Take it down for yourself, never tell you. Fraction, decimal approximation, variation, ratio, proportion, measurement, coordinate geometry. So fraction, decimal approximation, variation, ratio, proportion, measurement, coordinate geometry, and of course, our favorite, algebra. So you get now questions from each of those.
CSEC